Hello, my name is Daniel Perez, and I am going to be talking about user story ID 700, implement interaction to display object weight for puzzle 2. This is one of the user stories I implemented, and the description for this user story is, as a developer, I want to implement a function to show the user which side of the scale has more weight, so that the user can collect the necessary information to solve the puzzle. So this puzzle basically revolves around the user having to find the bad apple in a group of 7 apples. The bad apple weighs more than a good apple, and they have to use the scale in order to determine which one weighs more. So the acceptance criteria that I created for this user story is verify that the function succeeds if and only if apples are placed on the scale, verify that the function notifies the user if the scale was activated with no apples placed on it. And the reason for these two acceptance criteria is that we are recording the metrics for the number of times they use the scale, and if there's no apple or object on the scale, then there's no need to record that as a try. So that's the purpose of having those two acceptance criteria. The other acceptance criteria are verify that the function is able to read the weight of each apple and that the sum of apples on each side of the scale has the correct weight. Verify that the function plays an animation to notify the user that the scale is working when the user activates the scale to get the weight. Verify that the scale either tilts to one side or remains balanced depending on the weight when the user activates the scale. And verify that the function keeps record of how many times the scale was used. So for the use case, the actor will be the user, and the preconditions have to be that an apple has to be placed on the scale, at least one apple. So the flow of events is that the user activates the scale is going to calculate the weight of the apples on each side. If there are no apples on the scale, then the user is notified. Otherwise, an animation is played to notify the user that the scale is working. And then the scale just tilts to the side with the heavier weight, and the counter for the number of tries or the number of times the scale was used is incremented. Before I get into the UML diagrams, we used Lucidchart instead of Draw.io, and the reasoning for that is because we found Lucidchart to be much more intuitive and easier to use, since you can export and import images much easier than Draw.io, and it's just a much more efficient tool to use than Draw.io. So Lucidchart was very useful throughout the senior project. So the use case diagram is simple. It's just the user interacting with displaying the weight of the objects, and the sequence diagram is the user activating the scale, and then the scale gets the weight for the left and right plates, and the system is going to return a boolean called no apple, and if the boolean is true, then that means the scale is going to display that no apples were placed on there. Otherwise, the scale will go ahead and play the animation to let the user know that the scale is working, and then it will tilt the scale to whatever sides it needs to be, or it will just remain balanced depending on the weight. And then it increments the counter for the number of times the scale was used. So the class that I created is called scale weight displayer, and these are the variables and functions that I implemented, and we will be seeing that in a few. And the test cases for this user story are all related to verifying that the actions that the user does are executed correctly. So for example, checking for the actors, which would be the apples on the plates, getting the weights for the left and right side, the scale animation, displaying the weight, and incrementing the counter, which I would show this in the demo right now. So if we go to Unreal, we could go ahead and see, let's go to maps first, click on third person, and then, oh, okay. Alright, so then this is the room with the scale and the apples, and if we click on this apple, we can see that this apple has a variable which is 9, and this is the weight for that apple. That weight, the 9 signifies the apple that is poisoned, and the good apples have a weight of 8. So all the other apples that we will have in this room will have a weight of 8, and the bad one has a weight of 9. So this is how I give the value of what's a good apple and what's a bad apple. So if we play the game, and we try to activate the scale, we could see that down here in the output log, I'll do it one more time. Down here in the output log on the left side, you could see that it says warning, no apples on scale. So that goes ahead and shows you that you're not using the scale correctly. And then if we go here and grab the bad apple, which weighs more, and let's put this on the right side, and grab a good apple and put this on the left side, then we know that the scale should tilt to the right. So if we press space to activate the scale, it does the animation, and then it finally tilts to the right, showing that the right side has the bad apple. And now to show you the implementation of the code, if we go to Visual Studios, this is the scale weight displayer, and these are the functions that I implemented, which are activate scale, get weight, and display weight. Magic scale is a broadcast event which is used in Unreal to unify C++ code with blueprints, which I will show you in a few. And this is very efficient when you're trying to incorporate both C++ and Blueprint with each other. And then scale left side and scale right side are the arrays for holding the apples on each scale. So the scale has a trigger volume, and anything that overlaps that trigger volume, in this case the apples, will be stored into these arrays, the left side and right side. And then left and right, the integers, are what stores the actual weight of what's on those plates. Here in the class, we have activate scale. It gets the left and right weights. It initializes to 0, so it resets it. And then we get the weight for the left and right. And then what left and right does is it checks what overlapping actors are on that trigger volume, and it stores it into the array, which I initialize as scale left side. And then we traverse that array here, and with each iteration of the array, we get the actor, which is the apple, and we get the mass of that apple, and we add it to the left. And then we do the same with the right. We iterate through the actor's right side. We get the weight of all the objects on the right side, and we accumulate it to the right. And then this is where I check to see if they have apples on the scale. If the left weight equals 0 and the right weight equals 0, then I know nothing was placed on the scale, and therefore I notify them that no apples are on the scale. Otherwise, I display the weight for the left and right side. So display weight has three occurrences, which is if the left side is greater than the right, the left side weighs less than the right, or both sides have equal weight. So in each occurrence, what happens is I send an offset of the initial location of the scale. So if the left side is greater than the right, then it's going to tilt to the left, and therefore I'm going to set an offset of 3 for the height of the plate, so it can move and give that animation to notify the user which side is heavy or not. And I will show you where these offsets are being used now. If there is no difference in weight and both sides are balanced, then there is no offset. So if we go back to Unreal and we click on Scale Blueprint, this is where these offsets are being sent. So the first thing I do is store the initial location of all these three objects of the scale. So I store the initial location of the left plate, the right plate, and the top part of the scale. And in here, I save the initial location of these objects, the left, right, and top part of the scale. And then when I call the broadcast event, which you can see here in the C++ code, whenever I triggered the display weight, you can see magic scale broadcast. So this is connecting the C++ code with the blueprints. So So here, when we broadcast magic scale, I'm sending the offsets that I created, and it's gonna set it to a variable. And then we get the current, and get current is just gonna get the current position of these objects, the left and right side, and the top part of the scale. And then we're gonna play the animation so the user knows that the scale is working. And by the way the animation works is I add the vectors from the initial and the offset, or I'm sorry, the current and the offset, and it just plays a little animation of the scale moving around so the user knows it's working. And then I do a condition to check to see if the current position equals the new position. So if current position equals new position, I don't do anything. So I just, or otherwise, let me just say it this way. If the current position does not equal the new position, then I display the animation for which side the scale needs to be tilted to. So if they're not equal, then we will go ahead and display the weight of which side is heavier. So this would be like, for example, the right, if the scale is tilting to the right and it needs to tilt to the left, this would execute and it would do that animation for the user to for them to know which side has the heavier objects. And then after this executes, whether this is true or false, the condition, we're always going to go ahead and increment the number of tries that the scale was used, or the number of times the scale was used, so that we could record this to the metrics. And this is the and this is all the logic that is used for the scale. And now to show you the test cases to show how I did the unit testing, let's play the game right quick. So start the game. Actually, I'm sorry. I think this should be here already. Yes, it should. All right. So, So I'm sorry. So yes, we covered the no apples on the scale, but now let me show you the number of tries. So let's do this really quick. So if we just do this right here, and activate the scale, and then we go ahead and let's say we quit the game. Then right here on the bottom left in the output log, you can see that for room 1, the number of tries was just 1. So we verified that this part of the implementation is working correctly. And with that, that is my complete user story. And after I verified that all of my test cases were correct and everything was implemented correctly, I pushed my implementation and classes to my branch in GitHub, and that was it. So thank you for your time and have a nice day.